Hey everybody, so we're going to start 4.5. Alright, so now this is all about applying the properties of logarithms. Alright, so we previous section we learned what a logarithm is, how to evaluate logarithms, how to graph these logarithms. So now we're going to prepare ourselves for solving equations, which is the next section. There are three properties that we kind of want to go over, and we're going to go through them, see how to work with these properties, and then do some examples in working with the three properties. All right, so the first property is the product property. Okay, now the product property is, let's edit that. When you have a log of a product, now take a look, notice that m is multiplying n here. Okay, so in order to apply the property, what you're going to do is you're going to write the log of the first part of the product plus the log of the second part of the product. Notice that m times n, we split that product up into the two individual pieces. The first piece is m, the second piece is n, so we're writing it as log of m base b plus log of n base b. Now, a clever way to kind of remember this is if we go back and we think about exponents, right? So let's say we had the exponent of a to the m, of the expression a to the m times a to the n, right? So notice that this is a product, right? And what are you supposed to do with the exponents? You're supposed to add them, right? You're supposed to add m plus n. Okay, and that would be the exponent that you would have when you multiply. So same case here, since logarithms and exponentials are so closely tied, you have a product, okay, m times n, that's going to be split up into addition, okay, because addition, just like in exponents, we have the first part, the second part, okay, and that's pretty much how the product property works, okay. Let's go through the other properties. All right, so the second property here we have is the quotient property. Okay, so if we have multiplication, we usually have division in our properties as well. So this one, the way we're going to look at the property is we're going to have a quotient of two pieces or two terms, two expressions, right? So the same thing we're going to do here is it's going to get split up. So we're going to have log of m, the part of the numerator, minus the log of n. All right, again, similar to the one with the product, right? We have a to the m over a to the m. Now this is division, right? Okay, we see a to the m over 10 is dividing. What are we supposed to do with these exponents? I'm sure all you guys are saying subtraction by now. So you're going to subtract. That's why we use the same property here. We have division, so that's going to lead itself to using subtraction in the property. Okay. The third property is everyone's favorite because it tends to be the easiest of them. Okay, and that's called the power property. Sorry about that. All right, so now the power property, what it is you have the log base b of m. Now m is being raised to the n power. Okay, so now the easiest way to kind of think about this is that this m is occurring n times. So what we're going to have is we're going to have n times the log base b of m. Okay, now an easier way to kind of look at it is you're going to take this n as an exponent, and then that's going to shift to the front position of the logarithm. Okay, and then that's where we have it here. Okay, so these are the three properties. Okay, I'm going to try to zoom out without ruining this, see if that works. Okay, so those are your three properties. Okay, notice that we have the product, the quotient, and the power. So those are the three we're going to be working with a lot. Okay, and we're going to be doing things in both directions. All right, we're going to be taking certain logs that are already built as in the first position on the left side of the equation into the right hand side, and vice versa. Okay, so we're going to look at different examples that do with that. All right, And that's the majority of this section, is learning how to apply these specific properties, okay? So we're gonna start with something that's not too hard just to get into it, and then we're gonna go on from there, okay? So let's look at a couple of examples. Okay, so example 1. Oh, I'm messing this up. Okay, so we have the log, okay, of 4x. We're probably going to edit this part because okay, so we have the log of 4x with a base of 3. So the question is, what property do we see in this logarithm, right? So I see here, okay, that you have a 4 times an x. So that's the product property. So if you remember from before with the 3 properties, when you have a product, we are told that we want to split up this product. So you're going to have the log of 4 with base 3 plus the log of x with base 3. Okay, notice that the major operation we're using is addition, because again it's multiplication, and then we're splitting up our term 4x into the constant portion, which is the 4, and the x. Okay, so again, that is what you want to do with the 4x. Okay, notice we split this up here and here. Okay, all right, so let's look at a second example. All right. Promise these videos get better as we move on, right? So let's say we have the natural log of 15x, okay? So again, identify what we have in our problem. So we have 15x, okay? Now, what product do you, or what property do you see? Okay, so 15 times x, so that's the product. So again, we want to use addition, okay? We just have to identify what 2 logs that we're going to have. So the first log we're going to have is the natural log of 15. And the second log we're going to have is the natural log of x, all right? So again, we applied the product property, and this is what it ended up simplifying to. All right, let's look at another example here. So let's say we had, okay, let me scroll up a little bit. All right, we have the log of 3x to the 4th, okay? Okay, so now here's the first case where we actually have a power, okay? Notice that the power here is 4. The question kind of becomes, does the power apply to the entire 3x, or does the power only apply to the x? Okay, now, as you can see here, we can separate the 3 and the x to the 4th because the power only applies to the x, okay? So we actually have 2 properties here. We have the product and the power, okay? So what we're going to do is we're going to first split up the product. So the first part of the product is going to be log 3, plus the second part of the product is going to be log of x to the 4th, okay? Now, we're not done yet because the 4th power here is an exponent, and we actually have a property for that. It's the power property. So what we're going to do, okay, is we're going to write this as log 3, okay? And what are we supposed to do with the power again? So we know that the easiest way to think of it is we're going to take this power and drop it down to be the coefficient of the log, okay? So that's going to be plus 4 log x. Okay, now notice that again you have the 2 parts because you separated the 3 and x to the 4th, and then because the 4th was a power, that 4 went on to the front of the expression. Okay, so that is the way we approach this one. So again, this is the first case we have multiple properties, and you just had to apply both of those properties. All right, so let's start to get a little bit more involved. Okay, let's see what we get when we start to do some examples that may take a little more work. All right, okay, so our next example, we're going to do log of 5x to the second, y to the third, with a base of 7. Okay, so we need to identify what we kind of need to do here. Okay, so again, all we're really focusing on here is we want to identify the properties that we see here. Okay, now if you notice, the 5 is multiplying the x squared, and it's also multiplying the y to the third. Okay, so right there you should know that you have a product. Okay, so let's split up this product. So we're going to have log of 5. That's the first part of the product. That's the coefficient. The next piece of that expression is x squared. Okay, and then the next piece of that expression is y to the third. Okay, all right, so we were able to split this product into 3 parts, 5x squared, y cubed. Okay, now since it's a product, they're all going to be adding. Okay, you're going to have a sum for each and every piece. Okay, so let's continue. Okay, because I do see some other things we can do here. What are some other things we can do? Well, if we kind of take a look here, we have x squared, y cubed. What are we supposed to do with those powers? All right, so I'm sure you guys are already saying we need to move those powers to the front of the expression. Okay, everything else in the expression is going to stay the same, but those powers are now going to the front. All right, and then there you go. Okay, there's your completely expanded logarithm. Okay, nothing much else to do there. Okay, now I'm sure you guys are saying, well, we haven't done one with division. Okay, so let's look at one of those now. Made a mistake there. So example 5. Okay, let's look at one where we actually have to expand something using division. So here we go. We have natural log of 6x to the second over y to the fourth. All right, okay, so again, we have a bunch of things going on here. We actually have, okay, if you take a look, we have a product up here in the top. We have division, because we see the symbol here. And we also have 2 sets of powers. Okay, so we actually have all the properties just in one simple problem. All right, so the first thing you want to do is you want to split this quotient up from the numerator to the denominator. So I'm going to have the natural log of 6x to the second minus the natural log of y to the fourth. Okay, now we split up the numerator from its denominator. Okay, but notice that these two expressions still have a lot of work to do before they're completely broken down. All right, so let's continue to expand. Here I have 6x to the second. Notice the 6 is multiplying the x squared. So we're going to have natural log of 6 plus the natural log of x squared minus the natural log of y to the fourth. Okay. Now this one term that we had before is now split up into all its individual pieces. Okay, so now we just have to take care of any exponents that we have. Notice we have a power of 2 and a power of 4. Okay, so again, with those powers go to the front. Here's natural log of 6 plus 2 natural log of x minus 4 natural log of y. And there's your final answer, completely broken down. Okay, so again, that's as complex as it's going to get, where you're going to have every single property involved. But as long as you follow the rules of the properties, you shouldn't have any issues when it comes to expanding these logarithms. Okay, so again, the whole goal of these problems are we're taking something that was so condensed, like 6x squared over y to the fourth, and we broke it down into each individual piece. So we went from one logarithm to many logarithms. Some of you may say, why exactly are we going about expanding it? Well, understanding the properties in this form actually helps us when we need to condense it, when we go in the other direction, because then we actually are able to identify what we need to do. And condensing is definitely something that is helpful when we start solving equations in the next section. Okay? All right, so these were all about expanding. Let's continue a little bit. We're going to look at the ones now that are condensing. Okay, so those were expanding. We're going to do a nice little break here. Okay, so now we want to condense the expression. Okay, and to the condense, that means to, take something that's really big, more complex, and just make it simpler into one nice little logarithm. Okay, so again, we're applying the same properties. Okay, now let's just look at it in a different light. So here's our first example for condensing the expression. Okay, so we have log of 7 with base 4, okay, minus log of 10 with base 4. Okay, I got to learn how to finish my zeros there. Okay, so we see subtraction. Okay, if we're thinking backwards now, okay, what property should go with subtraction? Okay, that property is division. So we're going to take these multiple logs. Instead of writing multiple logs, we now have one using the property. Okay, now we have to identify which one of these is going to go into the numerator. Okay, I'm sure you guys are saying 7. 7 is correct. Okay, so 7 over 10. We combine this into one single logarithm. There you go. That's your final answer. Nothing else left to do. All right, so there you go. That's exactly how you're supposed to condense it. Condensing is a major key for when we're actually doing equations. So again, combining them into one is very, very, very helpful. All right, let's continue. Example 2. All right, let's say I have 6 natural log of x plus 4 natural log of y. Okay, so you see these coefficients, right? What do these coefficients represent? Okay, so that's the main key here. Is what does the 6 and the 4 represent? Okay, if you're saying an exponent, you're right on it, right? So it should be x to the 6th power, okay, plus natural log of y to the 4th power, okay? But we're not done just yet, because we need to ensure that from these two original logarithms, we're going to have one logarithm at the very end. Okay, so what's the next step we need to do? So I, again, identify that we have a plus sign here. So the plus sign is either going to be a product or a quotient. Okay, which of the two is it going to be? Definitely going to be a product. So natural log of x to the 6th, y to the 4th. Okay, and then there's your final logarithm. That's the single simplified logarithm where everything is within that one single logarithm. It just makes things a lot cleaner. Again, a useful skill, especially when we get to equations. Okay, let's take a look at one more. So let's say I have the log of 4 with base 5. Plus 1/3 log of x base 5. Okay, so again, we want to condense this as best as we can. We have multiple logarithms. Okay, so we just have to identify what we want to do first. Now, again, we do see two things here. There's addition and there's a 1/3 in the front. The addition is going to represent the product property. The 1/3 is going to represent an exponent. What we want to do first is we actually want to move the exponent to its correct position. So we're going to go log of 4 with base 5 plus log of x base 5 to the 1/3 power. Okay, so now the one thing we have to remember from chapter 3, okay, is that any number to the 1/3 power is the same thing as the cube root of that number, or that variable. Okay, so what I can do here is actually I can rewrite this next line as we have the same logarithm in the first position, the second logarithm, I'm just going to rewrite that as the cube root of x, because 1/3 power again just represents the cube root of x. Okay, and then lastly, okay, we have a sum here. So what are we supposed to do when we see a sum? That's going to be a product. So I'm going to take the log of 4 times the cube root of x with a base of 5. Okay, and there you go. That is your solution. Okay, so we did a lot of work in terms of applying properties of logs. Okay, so again, it's in preparation for the next section when we're trying to solve these equations. The last thing that we gotta learn is how to put any logarithm into a calculator. Okay, to do that, we actually have to do something called the change of base. Change of base. Okay, so what the change of base does is we're going to take any logarithm. So let's say we have a logarithm, okay, of A with a base B. Doesn't matter what the bases are, okay? So this base in the problem is B, okay? Now we know the calculator can only evaluate logs and natural logs. This has a base of 10, and we know natural log is the same thing as a log with a base of E. Those are the only two, okay? Now, what if B was not 10, not E? How do we put that into a calculator, okay? Well, you change the base to one of these two. And by changing the base to one of those two, you actually could put it into a calculator, okay? So now let's go ahead and see what the change of base formula looks like. There's actually two variants. The first variant is you're going to take the log of the A value over the log of the B value. Now, this log has a base of 10. We switched it to the base of 10 in order for us to calculate it using a calculator, all right? The other case, here's a big or, okay, is if we did the natural log of A over the natural log of B, okay? Oh, sorry, wrong letter. Natural log of B. All right, so again, you're just taking these two values that we see here and just understand that when we're doing the change of base value, the A goes in the top position, the base goes in the bottom position. The A goes in the top position, the base goes in the bottom position. Now, is there a real difference between log and natural log? There really isn't. Both of those are still going to give you the same result, okay? And I'll show you with an example here. So let's say we have the log, okay, of 5 with base 3. That is one that you can't do mentally, okay? So understanding how to change the base is going to help you when we need to evaluate it. So here we go. Let's say I have log of 5 over log of 3. That is going to be the change of base if I follow the same format, or I can also use the natural log of 5 over the natural log of 3. Okay, both of those are valid. Okay, so now we're going to use a calculator to kind of see how this works out. Okay, so please don't mind me where I'm trying to put these two together, and don't mind the sirens that we have here in West New York. Okay, so here's my calculator, right? I want to evaluate this here, log of 5 over log of 3. So I'm going to go ahead and click my log button, which is here. Let me go back to 5, close parentheses, and I'm going to divide that by, go back to log of, go back to the 3. Okay, so notice that my answer here is approximately 1.465. We always want to go 3 decimal places here. Okay, so 1.465 is the correct approximation for that log. Okay, so now let's take a look if we did the same thing with the natural log here. All right, so let me just try to get both of these on the same screen. Good. All right, so let me clear this out. All right, so now we're going to do instead the natural log of 5. Okay, and that's going to be divided by the natural log of 3. And we also get 1.465, okay? So it doesn't matter which one you use, okay? You're still going to get the same exact value, okay? So log or natural log, whichever you like, it's still going to be the same thing. And this is exactly how you evaluate it. You can use any logarithm. Oh, sorry. So let's go ahead and just do one more example because this is very quick. Let's say we have log of 7, or log of 12 with base 7. Okay, so that's either going to be the log of 12 over the log of 7, okay, or the natural log of 12 over the natural log of 7, whichever one you want to do, okay? So again, if we did it again, here we go. We have the natural log of 12 divided by the natural log of 7. We get 1.277. Okay, and then let's look at it in terms of the log. So let me clear this out, go back. We have log of 12 divided by log, go back, of 7. 1.277, beautiful. All right, so again, that's how we get the decimal forms of these answers. And again, another very useful tip for 4.6. So this section really all is just preparation for 4.6, where we actually start solving equations. Okay. Excuse me. So hopefully, you guys understood what was happening. Again, this is our first go at it. If you have any questions, please ask me on Google Classroom. Okay. I'm sure you already have seen what the homework assignment is, as it's posted. Should be posted underneath the video link for the particular section. Again, if you have any questions, please let me know. If you're wondering at what calculator I'm using, I'm actually using the Desmos calculator. Okay, so if you have a tablet or you have the PC or Chromebook, just go to Desmos, and Desmos can easily do it for you. For iPhone users, don't forget, if you're going to put a logarithm into a calculator, everything is backwards. Okay, everything is backwards. All right, so again, you'll have this video. I'll post the notes as well. Hopefully this helps out. Okay, I'm hoping that this all works out really nicely. But again, thank you for your time. Please leave a like and comment down below. All right, thank you, and enjoy the rest of your day.